Here we're just going to have a look through some of the theory behind quadrats and the core practical that goes with it at GCSE. So quadrats are a way that we use to estimate a population, normally of very small organisms or things like plants that don't move. Now, to put that into perspective, if I have a field of cows, it's quite straightforward. All I do is I count the number of cows in the field. If they're sort of a little bit more manoeuvrable over a bigger area, what I would do is maybe do something called a capture-recapture. So, for example, if I had rabbits, I would put a little tag around their, I'd capture 10, put a tag around their ankles, they hop off. A week later, I collect them all back in, and I see how many have got tags around their ankles, and then I can figure out the population based on what percentage came back. Now, that's ways we can measure those. However, things like plants are quite easy because they don't move. So we would use a quadrat. And if I give you a field and you have to figure out the number of daisies on that field, this becomes a lot trickier because that would take you forever. There's no point in capture and recapture because they're not going anywhere. And there's so many of them that it would take forever to do. So we estimate the population. We do that using a quadrat. So this is what a quadrat looks like. And it's 1 meter by 1 meter. And what you would do is you would count the number, you'd place it randomly, and you'd count the number of organisms within that quadrat. So 1, 2, 3, 4, 5, 6, and there is a 7th one here. So we've got 7 daisies in that quadrat. And you'd throw this several times and you'd find an average. And I'll talk more about that on the next slide. How you count them depends on the species. So within daisies, because they're these small white flowers, they're very easy to count. Something like these dandelions that are very big, these would be harder to do. So you've got 2 for definite, and then this one's sort of half in, half out. So as long as you always count it the same way, it doesn't matter too much. So you could count this as 2.5. You could count this as 2 because you could only count the ones that are actually in there. Or you could count it as 3 and say that any that are in there at all count as 1. So any of those options are possible, just as long as you always do the same thing. So how do we use this? Well, let's just say, hypothetically, this is my field, and I'm measuring this area here, and just making up some numbers, just to make numbers easy, that's 100 meters by 100 meters, and I've got that square area there, okay? What I'm going to do, there are 2 ways of doing this. I could either randomly throw those quadrats around the field, okay, and that's quite difficult to make perfectly random because you'll tend to either aim, or if you start over here, the majority of your quadrats will end up in this area and this area goes forgotten about. So that's one way of doing it. The other way of doing it is to do what's called a random generator for locations. You can get one of these quite easily on your phone, and you can calculate the distance, and it'll divide it into a grid, and it will say where to place the quadrat. The other way to do it is called a belt transect. Now what you would do is you would put a string or something across there, and every, let's say, 5 meters, you would put the quadrat along that string, and that will give you an even distribution across the field, and it will be randomly placed. So that's another way you can do it. That's also a particularly good method if you're looking at something like the difference between light and shade. So that would be called a belt transect, and that would make it random. Now, if we look at the previous one, we had 7 daisies. Now, let's just say that that is the average. So I've got 7 daisies on average per quadrat. What I would then do is I would need to figure out the population of the field. Now, if there's 7 in a quadrat and the field is 100 by 100, that gives me 10,000 meters squared. So if the average is 7 per meter squared, and then I've got 10,000 meters squared, the population, estimated population, would be 70,000 daisies in total.